Hello everyone, welcome to our second lecture on statistics. So in this chapter, we're going to look into scalars and vectors. So the objectives of this course, you'll be able to know the definition of scalar and vector, know the basic scalar math operations, addition, subtraction, multiplication for vectors, and we'll know how to use the parallelogram and triangular laws to sum vectors. Then along axis, not always perpendicular. Know how to find vector sum using geometry laws, sine and cosine. So let's look into what is scalars and vectors. I hope you recall what is scalar and vector. So the scalars are positive and negative physical quantities specified only by magnitude and they don't have any direction. In case of vectors, they have magnitude and also they have a direction. And let's see the figure shown on the right hand side. So this is the normal notation of a vector which shows us the tail part and then you have a head part. So this head part shows us the line of action, that's the direction and what's the. So this length of our vector denotes what's the magnitude of our vector. So the examples of scalars are usually length, and then we have mass, time, and then we have density, temperature. And the example for vectors are we know force, which have direction and magnitude, moment, displacement, velocity, and we have weight. So vector operation, so what happens when you multiply and divide a vector by scalar? Let's assume we have a vector which is A. So what happens if I multiply this vector by -1? So multiplying 1 has the same magnitude of our previous one. Because I have a -1, that means it's an opposite direction because vectors deal with directions. So you can see how the direction has changed in our second figure. Same thing, you have an A magnitude of vector and then you multiply by 2 and then you get the double one. And then you have 1.5 times of your A but the direction is opposite. So whenever you multiply a vector by a scalar, it's just multiply the magnitude of it and if it depends on the positive and negative terms whether it changes the direction or not. Next one is about vector addition. So let's say we have a vector A and B. So how do we do the addition of them? For that, first we bring the A and B together at a point where they meet. Then we're going to draw a parallel line to B and then to A. And we get the point where it meets. We're going to draw a vector from A. The point where it meets is going to be its tail. And its head is going to be where the parallel lines of A and B meets. So that's our vector. So for addition of vector A and B is given by this vector R. So what happened in triangle rule? Similar to that, we do the only half portion using a triangle. So we have A and B. So we start first with A. So we draw the A and from the head of the A we draw the B which is parallel to this B. Then we can get our vector pointing out this direction. So both parallelogram theory law and also our triangular laws gives us the vectors in the same directions. What happens to our addition of collinear vectors? So what is collinear vectors? So the vectors will apply in same directions. For example, let's consider vector A and 2A. So they are acting in the same direction. What happens when you add both of them? So what happens is it's just going to create the vector in the same direction because no change in the direction because they are collinear and it's just the addition of both two and it gives a 3A. So this will happen when you add two collinear forces. Not only for horizontal one, same for vertical one. If you have two vertical forces, the resultant is going to be vertical, and if you have two inclined forces, then the resultant is going to be an incline. Let's move into the vector subtraction. It's going to be the similar to addition. Instead, we have a minus. So what are we going to do with the minus? We just put in plus and then we change the direction of B. So let's see how we are going to add A and B. So similar thing, we have A, but instead of B, it's not going to be this direction. So it's an opposite direction because it's negative B because that's A minus B. Then similar thing will be done for our triangular construction. Let's see how to find the resultant force. Let's say we have forces F1 and F2. So first we use the same parallelogram rule is addition of forces. So the resultant is going to be F1 plus F2. So what are we going to do? Let's start from F1 and then you draw the F2. which both forces, and then you know the parallel ones, and then your resultant will be this. And for triangle, let's start with F1, and then you go to F2, and then you're going to have your resultant like that. So it's same to the addition, so you get the resultant by adding the forces. Now let's see, find the components of forces. So let me see, I have a F force acting, and I have a horizontal, I have a two axes, which is, I'll mention it as U and A, U and V. So I want to resolve this force in U direction and also in V direction. So how do we do that? So I take the F force and the one in the U and V. So let's take the FU and FV, so such that the resultant will be the direction of our F. So what happens if we are going to add several forces? So we looked on to addition of two forces, but what happens if you want to find the resultant of many forces acting at the point? So let's see, we have forces F1, F2, and F3 acting. So how do we get the resultant? It's simple. First we take F1 and F2 and we deal with it as two forces. Then we get the resultant, which is F1 and F2. Once we have F1 and F2, and then we have the F3 remaining. So we consider that as two forces in a system, and then we get the resultant. And if we had more forces, we keep on going in the same way. So procedure for analysis. How are we going to analyze the problems of addition of forces? First, we say we use parallelogram law. So first you make a sketch by placing the vectors together at their tails and showing vector addition using parallelogram law. So the two component forces add according to the parallelogram law, and then they yield a resultant force, which is the diagonal of the parallelogram. So if the force is to resolve into components along two axes, directed from the tail of the force, then start at the head of the force and then construct lines parallel to the axis, thereby forming the parallelogram. The sides of the parallelogram will represent you the components. Now you label all the known and unknown force magnitudes and the angles on the sketch and identify the unknown knows. Same thing we can use with the trigonometry. So what are we going to do with the trigonometry? We're going to use sine law or cos law to find out our unknown forces and unknown angle. So what is our sine law? So sine law relates the angle opposite to the each sides and the for example, if we say A by opposite angle sine A, and then we take B and the opposite angle sine B, and then C. And cosine laws, if you want to find out the angle side C, so if the C is going to be the A squared, B squared, two angles, other two sides minus 2 times the length of the other two sides and the angle opposite to the C. Okay, let's solve this problem. You can solve this problem on your own. So you need to find out the resultant of F1 and F2. So how do we do that? So first we need to find out where the resultant is going to be. So we know how to draw that. We're just going to draw a parallel line to F1 and F2. And we know how the resultant is. It's going to be here, right? That's going to be our resultant force. And now our task is to find the resultant force. But for that we need to know how many angles do we know. And do we know any angles? So we are given 15 degrees and 10 degrees. So how do we find out the angle? So we know this is 15 and that's 10, and here we have 90 degrees. So Between this F1 and F2, we know what's the angle is going to be. That's 90. So that's going to be 90 minus 25. So we get 65 degrees. So we know that is 65. So what else can we get? So this is going to be 65. We know that in a parallelogram, we know that is going to be 65. And so then these two will be like 360 minus 2 times 65. So we get that as 150. So we have the figure here. So we get 150 there and 65, 65 here. So we can take any one triangle to find out FR. So we know the angle opposite to FR is 150 and we know 100 and this is magnitude is 115. So we can use cos rule to find out our resultant force. So using cos rule, you get 100 square plus 150 square minus 2 times 100 into 115 cos 115, and when you get the magnitude of resultant force as 230. Or else you can use sine laws to determine the theta, that's the angle where the resultant is going to be acting. So that's going to be 150 over 50 sine theta is equal to your resultant divided by sine 50. And that gives us 39.8 degrees. Okay. So we get the phi angle, that's going to be our 15 plus 39.8. So what's our phi angle? So we get the angle where the force resultant force is acting is going to be our phi. So that's what we get it. So always when you're giving a resultant force, you should get the magnitude and the angle whether it's acting. So we have the resultant force that is 213 and the angle that's acting from horizontal is of 54.8 degrees. Okay, so now we have find out the resultant. Okay, so now you can resolve this problem on your own. So resolve the horizontal 600 pounds force into components acting along the U and V axis and determine the magnitude of those components. So here you can use the sine rule. So we know how to resolve those forces in the U and V direction. So you're asked to find out what is the forces in V and U. So just a hint for that, your forces is going to be acting FV and along that. So we draw the first FV, and from the head of FV you're going to draw the FU, and then your horizontal force is going to be your 600 pounds. So with that you can find out, use the sine rule and trigonometry to find out the answers. You can try it on your own, and the solution for this problem is given in example 2.2, so you can refer to the example.